are recording? Now, in our note sheet, essentially, we're going to be talking about quite a few things involving trigonometric graphs. Trigonometric graphs. And I'm hoping that we were able to successfully graph our sine curve and our cosine curve, and we get the gist of it. The sine is at odd or even? Sine odd or even? Odd. And cosine is even. Perfect. So now, take a look at the screen, and I'm going to graph the cosine graph real quickly. Now, if I were to do something where I call this a parameter, and I'm going to say A, what would happen if I multiply A to my cosine graph? Is that changing the graph of the function right now? No, but when I change A's value, do you see how how the graph changes? It's really changing a vertical stretch. Everybody there? Now, that A is what we call the amplitude of a sinusoid. So you see that on your notes. The amplitude of a sinusoid, f of x equals A times the sine of bx plus c plus d is A. Similarly, the amplitude f of x equals A cosine bx plus c plus d is the absolute value of A. Graphically, the amplitude is half the height of the wave. So, for A, example 1, what is the amplitude for A? Anyone? 1. What is the amplitude for B? 1/2. What is the amplitude for C? Positive 3, okay? Because we're asking for half the height of the wave. Everybody okay with that? Amplitude is really easy. And it does not matter whether we're working with cosine or sine. Now, the period of a sinusoid is the length of one full cycle of the wave. So if I'm going to mix it up, and I'm going to work with my sine curve. The sine curve, you notice, goes through that origin. If we start at the origin, at what point does the graph begin to repeat itself? If we start at the origin, at what point does the graph begin to repeat itself? 2 pi comma 0. Is everybody okay with that? So the period of the sine curve is 2 pi. It's really the horizontal distance before the curve begins to repeat itself. Okay? Now, as we think about this, a lot of you all love formulas. Don't you love formulas because it makes your life easier and all that type of stuff? If you had y is equal to a sine bx plus c plus d, the period here is always just 2 pi divided by the absolute value of that b. Okay? So in this example here, y sub 1 is equal to sine, I guess, 1x, right? So we're taking 2 pi divided by 1, and we get that. So for b, y sub 2 is equal to negative 2 sine pi thirds. What's the period of that wretched function? We would take 2 pi divided by pi thirds. Is that 6?
Yes.
Y'all see that? And if you need practice, isn't that just 2 pi divided by 1 times 3 divided by pi? My pi is divided out. 2 times 3 is 6. Now, let's think about how that works in relation to transformation. The period here is 6. If I have x divided by, did I just put pi thirds there? That was a bad Burkhead. I read that incorrectly. So it should just be 6 pi. The period 6 pi in this example. And Miss Burkhead really reads that as an x. And this is a subtle reminder that maybe I need more glasses. Maybe I need that. Okay? I need better glasses. Everybody okay? So we get 6 pi. You still have this 2 pi divided by b. I didn't mess up any math. I just read the wrong. Okay? And I'm okay if I messed up math. So for part C, it says y sub 3 is equal to 3 cosine negative 2x. What would the period of that part C be? It would just be pi, right? And what I'm trying to hear, when you just saw that, if I replace x with negative 2x, that's reflecting cosine in what axis? The y-axis? That doesn't mean a thing because cosine graph's already even. You get what I mean by that? But if I replace x with 2x, what does that do? Shrink or stretch the graph? It shrinks it. And doesn't that make sense that the period is also shrunk? Everybody there with me? Agree, disagree? So, if you want a little bit more on the belief end, we graph this function. I could still bring the idea of a parameter. I'll call this b. If I change this to b times 1, and then I change b, do you see what happens? Okay? So that it's working with the period. Hopefully this helps. Can you imagine mathematics without Sketchpad? I mean, come on. I know that some of you all had this class last year that doesn't use Sketchpad, but I could use Sketchpad for any math class. Okay, is that working for everybody? Okay, so that's the period. Now, the next set of problems we have would involve the frequency. The frequency of a sinusoid, as stated in the directions, is essentially the number of complete cycles the wave completes in 1 unit interval. 1 unit, okay, 1 unit of interval essentially is what the frequency is. Therefore, if you're liking formulas, the frequency is always the absolute value of b divided by 2 pi. So, for example 3, it says find the frequency of the function 4 sine 2x divided by 3 and interpret the meaning graphically. Well, what would the frequency be? What is our b? Anyone? Anyone? 2/3. Everybody okay with that? Okay, so the frequency here is equal to the absolute value of b, 2/3, divided by 2 pi. Everybody there? So here I have 2/3 times 1 divided by 2 pi. Is that just 1 divided by 3 pi?
Did you say 1 divided by? Oh, okay.
I think I did okay.
Yeah.
I really do. But watch me. I'm so human. Everybody's okay with that. Now, what that means is, do you all see this little unit point? That defines what 1 unit is. And what they're saying is 1/3 pi of the graph is plotted from 0 to that unit. That's what that means. How many of you all have worked with frequency and sound? You know sound? What? Okay, Duncan, explain it to me, because I'm still trying to figure it out.
Like what it represents?
Yeah, just kind of talk about it for me.
The shorter the frequency, the higher the pitch of the sound.
There you go. Now, look at this, my friends. I could have something like A and a 1, and let's do something wild and wacky. Maybe let's do something I do on Fridays. A times 1000x. What's that going to look like? Look at that function. Okay, now I'm going to listen to that function. So let's do it. So what I'm going to do is I'm going to select this function's graph. I'm going to go to Edit Action Button Sound. And I'm going to listen to this function. See? Just as Duncan stated, I'm increasing the frequency, and notice how it's getting higher. I don't hear that. Age, there is one benefit from age, and I'm just kidding. That, and I can eat cookies tonight for dinner.
I don't know. I can do that.
Okay, but that's mildly interesting. Yes, no? So we just took care of... Yes, Kevin.
So is that like over time? Like
Yes.
It starts?
Yeah. It's doing it over time. Yeah.
And it's in seconds.
So had I just done this, had I not divided it by 8, it's going to be a constant. But now I'm changing it. And you can never say that I don't show you some sort of application in mathematics. And? Okay.
Oh, okay.
So, now, let's give this a whirl. What if we had, oh, Carrie's going to hear that on on YouTube. She's going to hear that. Okay, that's cool. Okay, so let's get through this example, save it, and then I'm going to make a new file. But let's look at f of x is equal to 4 sine 2x divided by 3. Because what Ms. Burkhead might first ask is, what's the amplitude of that function? How many people are like, I'm down with the amplitude, man. I got it. What is it? It's 4. Okay, what's the period of that function? 3 pi.
3 pi.
2 pi divided by 1 times 3 divided by 2. So I would agree 3 pi. And then the frequency, you can just take the reciprocal of the period, right? 1 divided by 3 pi. Is that making sense? Now, since this is a sine curve and we have no translation horizontally, is this graph going to go through the origin? Yeah, we don't have a horizontal translation. And think about it. If you plug in a 0, the sign of 0 is 0, so 0, 0 is part of it.
Whoa. So 0, 0, 0.
You don't need me to give you another unit circle quiz. When you ask those kind of questions, that makes me think I need to give them a quiz tomorrow on the unit circle.
Can we please? Yeah, can
Yes.
Yeah, actually,
That
that's
Okay. So, let's get through this problem. Our period is 3 pi. So I'm going to go here to 3 pi. Now, if we just looked at the sine curve, the typical sine curve, I'm going to make it dashed because I can. On that dashed curve, it's still going to be stretched vertically by a factor of 4. Is everybody on board with that? But do you notice that with the typical sine curve, a quarter of the way you're at a high, 3/4 of the way you're at a low, right? So I'm going to have to go a quarter of my 3 pi. Everybody on board with that?
Yeah.
So a quarter of my 3 pi. 3 pi divided by 4? Is that making sense? A quarter of my 3 pi. Well, okay, first, I know that at half my 3 pi, I'm going to be at, where? I'm going to be at my origin again. Is that making sense? Because you all see that you're, not the origin, but the trigonometric axis. Everybody there? So, between these two values, I'll be at my high. And then between these two values, I'll be at my low. And so then we just plot it. Typically, it would be great if you'd plot 3 cycles. But I told you to go from -3 to 3, so we can only plot 2. Here we'll be at a low. Here we'll be at a high. So, does that kind of help? Kind of, sort of?
You made things a lot more complicated. It's just a tad confusing.
All right.